Converting between rectangular or Cartesian form and polar forms of a complex number. We saw in the example that z1 was 2 plus 2i. That's a Cartesian form. And we found that the modulus of z1 was 2 root 2, and the argument of z1 was pi by 4. Using these, we can express the complex number in polar form. We say that z1 is 2 root 2, then open a bracket, cos pi by 4 plus I sine pi by 4, close bracket, which is often written as z1 is 2 root 2 cis pi by 4, and the cis is a cos plus I sine contraction, just to make it easier to write down. Expanding the polar form out, so we're going to expand the bracket here. So z1 is 2 root 2 cos pi by 4 plus I sine pi by 4 gives us 2 root 2 cos pi by 4, and then we do this one and we get plus I 2 root 2 sine pi by 4. Now pi by 4 is one of our standard angles, so we know the cosine of pi by 4, we know the sine of pi by 4, and both of those can be written as 1 over root 2. So the root 2's here are just going to cancel, and we get back to 2 plus 2i. So we can convert polar to Cartesian by simply expanding and evaluating. When converting Cartesian to polar, we need to do what we did in the example. Calculate the modulus, calculate the argument, taking care to get the angle in the correct quadrant, so a sketch is always recommended. Suppose the modulus is a and the argument is theta. The polar form is z is equal to a cos theta plus I sine theta, which we can always contract to z is equal to a cis theta.